Okay, what's up? So, today we're going to keep talking about what we've been discussing. So, you might remember that we were talking about probability distributions last time. So, I'll start off with reviewing that concept, and then we're going to go into new material, which is about random variables. Okay, so let's do that. Oh, whoa, my thing just whoa, what just happened? My little picture just okay, that became a tiny little thing. Guess I can fix it. There we go, I'm getting bigger. There, okay, I've returned to the screen. It's been a great day. It's canceled. Minimum wage is living wage. Oh my god, yeah, I know. I don't know what the chances of that are, though. I'm afraid to tell you. We'll see. Maybe. I'm not very sure. Cracks in capitalism. Yes. Yeah, it's oh my god, that's like that scene in, what's it called? That one movie, Dumb and Dumber. So he's like, so you're saying there's a chance, right? Oh, man. Yeah, capitalism. It's a hard knock life in capitalism. The, slave owners know a lot about social control and what to get people to do what they need to do, and we all need to eat, and all of that. So, I don't know if there's escape from the system. But we continue on, and we try to be nice to each other, I guess. I don't know. Interesting thing. So, on that super happy note, let's talk about statistics. Woo, woo, woo. Okay, one second. Plug it in my thing. My little drawing thing. Neutral. What's that? Are you voting? Karan? Is it Karan? Karan or Karen? I don't know. It's Karan. Oh, okay. Yeah, because I saw it, I didn't know. I was like, it makes me think of Karen, but I was like, I don't think that's what that person's name is. And I was like, I don't want to say Karen, but I was like, I'm not sure what I should say. So thank you for telling me. I'll say it like Quran. Is it supposed to sound like the Islamic holy text? Yeah. It's one of those things where I guess you never really know. But yeah, I was actually wondering that. Like, when you said it, I was like, oh yeah, the Quran. Like, it could be the Quran. I don't know. So anyways, let's do this! Okay, we are going to talk about random variables. So, let's remind ourselves, what is a probability distribution? So what does it have in it? It has all of the outcomes. And all those outcomes need to be disjoint. Does anyone remember what it means to be disjoint? What does it mean if outcomes are disjoint? Think back. I know it's been a while. Time all bleeds together. Yeah, exactly. If one thing happens, another one can't. So if one event happens, the others can't. Okay, so a probability distribution is a list of all the outcomes with their corresponding probabilities. Then prior to this, we talked a bit about different rules for calculating probabilities. So now we're going to keep going forward with this. So let's make up an example. So let's say you're playing some sort of game. And oh, I know. Let's like say that you're playing like the lotto. So let's say that like the possibilities are that you can win $0, $1, $10, $100, or $1,000. Little lines right here. So obviously if you win $1, you can't win like the other amounts, right? If you win nothing, you can't win the other amounts. So these are disjoint. Let's say that you're playing some sort of like lottery type game, and this is the possible outcomes. Okay, so let's assign some probabilities to this. Let's say that 60% of the time you win nothing. Oh damn, there's like not much left. 60% of the time you win nothing. 20% of the time you win $1. Let's see, that's 80. 10% of the time you win $10. So how much is that left? 80, 90, we have 10% left. Actually, let's make these a little bigger. Let's go back. Let's make this 60, 30. So that leaves you with 10% left. 8% of winning, 8% chance of winning $10. So that's 98. A 1.9% chance of winning $100. And a 0.1% chance of winning $1,000. Okay, so we have basically the outcomes here for what you're expecting to happen. Or sorry, for you have the outcomes, all the different outcomes with their corresponding probabilities. So what we have here is a probability distribution table. Okay, now thinking back to what we learned about probabilities, what do they mean as far as we're concerned? So remember we talked about like how you should interpret probabilities? Like how are we supposed to interpret these probabilities? I know this was a while ago, but think back. I told you that there's like different ways to interpret what probabilities mean, and in particular we were a what's the word? Frequentist. We're going to be using the frequentist interpretation. So there's like something weird about like what these numbers mean. Like what does it mean to say that there is a 60% probability of winning nothing? Yes, but there's like a very special way we have to say it. Like what has to happen before you like look at like the proportion of times that happens? After what? There we go. So probability is when you're looking at the proportion of outcomes after an infinite repetition of trials, right? Like the whole idea is like you would play the lottery like an infinite number of times, and then after those infinite number of times that you've played, 60% of them would be losses, 30% of them would be $1 wins, 8% of them would be $10 wins, 1.9% of them would be $100 wins, and 0.1% of them would be $1,000 wins. So this is the proportion of outcomes after an infinite repetition of trials. Good. So you have to keep that in the back of your mind, right? Like this is like a statement about after an infinite number of trials. So we have a term, and it is called the expected value or average of the probability distribution. And what is that? So basically, it's asking in this case, how much money would you expect to win if you played once? So obviously we know that if you play, or we have this statement like, if you were to play, we believe there's a 60% chance that you would win nothing. If you were to play like an infinite number of times, there's a 0.1% chance that you would win $1,000. But how much money would you expect to win if you played only one time? So we call this the expected value. It's also called the average of the distribution. So the average and expected value are the same thing. And there's actually a formula to calculate this. So if we talk about the expected value, we write E of the name of the variable. So like if you had a variable called like lotto, you would say, hey, what's the expected value of winning the lotto? So how much might you expect to win? To win on average if you played an infinite number of times. Okay, so this goes back to this idea that we're always talking about like after an infinite number of times. Okay, so there's two ways to write this. You can write E expected value of the variable, E of the variable. Another way that it's sometimes written is you write this symbol called a mu, and then the name of the variable right there. So we might also write it as mu lotto. They mean the same thing. The mu, mu, is the Greek letter. It looks like a U with a line right there. Like a line in the front. Does everyone see how I started with a U and then you put a little line in front? It's called the Greek letter mu. Okay, so mu and the expected value are the same thing. If we talk about the average, how much would you expect to win if you played an infinite number of times on average? Okay, and there's actually a way to calculate this from the probability distribution, but I'm going to wait a second because I think people are writing. Okay, so the way that you calculate the expected value of your variable, I'll just write X for your variable, is what you're going to do is the outcomes, these numbers up here, I'm going to call these my X's. So what are my different outcomes? I can win $0. I can win $1. I can win $10. I can win $100, and I can win $1,000. So each of these is going to be called a different X. I'm going to call the first one X1, the second one X2, the third one X3. Actually, let's rewrite this. Sorry. So I'm going to say X1 equals 0. My first outcome is I win $0. I'm going to say X2 equals 1. My second outcome is I can win $1. x3 equals 10. My third outcome is I can win $10. x4 equals 100. My fourth outcome is I win $100. x5 is 1,000. My fifth outcome is that I can win $1,000. Those are my 5 outcomes. So it makes sense I'm always going to call them x1, x2, x3, x4, x5, however many outcomes I have. Right? So you know which one you're talking about. Okay, now along with these things, you have the probabilities. Okay, so what is the probability of the first outcome? Well, 60% is 0.6. What is the probability of the second outcome? Well, the second outcome was 30%, that's 0.3. What's the probability of the third outcome, which is $10? That's 0.08. So notice I write all these as decimals. What's the probability of the fourth outcome? Actually, let's move these so it's not like in the way. There we go. There, that's better. So what's the probability of the fourth outcome of winning $100? 0.019. Let's move this some more. It's in the way. There we go. What's the probability of the fifth outcome, which is winning $1,000? 0.001. So notice that each x value, each outcome, has an associated probability, a p-value. Right? So x1 goes with p1, x2 goes with p2. Mucho bueno with that so far? And we get these from the probability table. Okay, so that you would expect to win after playing an infinite number of times is you're going to do x1 times p1 plus x2 times p2 plus x3 times p3. And you keep doing that until you get to your last one, which in this case is x5 times p5. Okay, so you're going to multiply all of the outcomes by their probabilities and add them together. So let's do that. So our x1 is 0, and the probability of that was 0.6. Our x2 was 1, and the probability of that was 0.3. Our x3 was 10, and the probability of that was 0.08. The fourth outcome, x4, was 100, and the probability of that is 0.019. The fifth outcome was 1,000, and the probability of that happening was 0.001. So you can go to Wolfram to calculate this because it's a calculator. You can just type all these in. I'm going to quickly do that so we can see what this number is. So bear with me while it loads. Yeah. There? Cool. Okay, so I'm calculating this. Typing it in. Okay, if you were to calculate all this, if you were to do your 0.0 times 0.6, 1 times 0.3, 10 times 0.08, 100 times 0.019, 1,000 times 0.001, that ends up giving you 4. So you might now wonder, like, what does that mean? So this is the quote-unquote average payout. Okay, that means, you might be shocked to hear this, if you were to play this lottery an infinite number of times, at the end, how much money would you have made? $4. That's like what we would expect, basically. Yeah, I know. This is why statistics and probability are like really interesting. Because, and actually this is sort of how capitalism works. The whole system is like rigged. Like they already know what the expected value is. So they can actually sort of like figure out like what they're going to pay out to everyone from the beginning. That's how casinos operate. And actually, if you really want to be, what's it called about this, you should, we should do this slightly differently. So how much does the lotto usually cost? Like how much is one of the like lottery tickets? Does anyone know? I don't play the lotto, so. Okay, cool. So we need to like be very careful here because we're not taking into account that you're paying for the ticket. So when you actually win $0, did you come out ahead or did you lose money? Like if you win nothing, like what's your outcome? Yeah, you're down $2, right? -2 means you lost $2, right? It's not that you didn't get anything, you lost $2. If you win $1, what's the actual like outcome for you? Yeah, so you're actually still down $1. Okay, so if you win $10, you've actually won $8. Oh, yay. If you win $100, you're actually up $98. And if you win $1,000, you're actually up $998. Okay, so really when you calculate this, you should take into account the fact that you paid money to play, right? So does everyone see how now I've actually taken into account like the fact that we spent $2? So taken into account the fact that tickets cost $2. Okay, and then you still have your corresponding probabilities. 0.6, 0.3, 0.08, 0.019, 0.0001. So now if you multiply these and add them all together, you're actually going to get a slightly different number, so I want to go and pay homage to that. So you're going to get -2 times 0.6 plus -1 times 0.3 plus $8 times 0.08 plus $98 times 0.0019 and then $998 times 0.001. And actually, if you take that into account, your expected winnings are $2. Which makes sense because the $4 before, that didn't take into account that you spent $2 to play it each time, right? So actually, your expected winnings are $2 at the end of it. Boom. So, sadness. Yeah, but then remember we have the law of large numbers. Actually, if you play a sufficiently large amount of times, no matter... So here's the thing. Like, imagine, like, you played the lotto, and a couple times you, like, won the quote-unquote $1,000 jackpot. If you kept on reinvesting your winnings into playing the lotto again, at the end of it, you'd only be left with $2 of winnings. Because most of them would end up being losses. So the more you play the lotto, the closer and closer you're going to get to the $2 payout. Well, no, because someone always wins. Statistically speaking, the average payout is $2. But can you even win $2? Like, what are the different outcomes that we have here? Like, what's the worst outcome you can get from playing the lotto? Right, and then down $1, up $8, up $98, up $998. Notice that the average payout isn't even an option. That's because this is assuming that you keep on playing over and over again, so your $8, $98, and $998 payouts would balance out with the -$2 and -$1 payouts until after the end of it, you'd see that you only won $2. You'd be $2 up from when you started. So really what you're hoping is that at some point you win and then you stop playing. Because if you keep playing, what's going to happen to your winnings? They're going to go back down. You're going to get closer and closer to that $2. Does that sort of make sense? It's like people stop playing the lotto once they hit jackpot. Like, there's no point in, like, reinvesting your winnings back into the lottery. Wait, say that again? No, it works the same. Well, let's talk about that. That's a good question. Okay, so it's a little more complicated though with blackjack because you can decide how much you want to bet. Oh, okay. Yeah, so let's look at slot machines. So let's have a super simple slot machine. So let's say the slot machine is 2 coins. So you could do heads and heads, heads and tails, tails and tails, tails and heads. So does that make sense? You look at your little thing and it's one of these 4 outcomes. Right, like you would look, you'd spin here, like let me draw their little, here's like the little wheel, and then there's like a little dial right here which says an H or a T, and there's a little dial over here which says an H or a T. Right. Okay. Yeah, I have a beautiful drawing, right? So let's call this outcome. So this outcome, how much does it cost to play this thing? Just make up a number. Well, let's just say $1 to make this calculation simple. Each time you play, it's $1. Okay, now let's say that all of these are losses, except for tails. So loss, loss, loss. What will the payout for tails and tails be? How much will the win? Let's make it worth a win for $2. Sound good? Okay, so you put in $1 and sometimes you win $2. Okay, so now you start making your probability distribution. Each time you play on the other ones, each is $1 loss, right? Okay, so what is the chance that you have $1 loss? There's 4 different outcomes and 3 of them are losses. Yeah, so 75%. Now, if you win $2, how much did you actually win? Yeah, because you played $1 to play, right? And you got $2, which means you're up 1. Now, what is the probability of that happening? Right? Okay, cool. So your expected winnings after playing this forever are -1 times 0.75 plus +1 times 0.25, which is -0.75 plus 0.25, which is -0.5. So in other words, at the end of playing that slot machine an infinite number of times, what's the likely outcome for you? You're down 50 cents. You actually paid to play a game, basically. That's how slots are rigged. Did you know that? That they actually just choose the probabilities, these numbers here, so that when they do the expected value, they make sure that it's negative, which means that at the end of everybody playing, they will have made 50 cents from everyone. Which is why do you think the drinks are free in Vegas? They're not. It's because the drinks are cost into it. Has anyone ever, oh shit, most of you probably aren't old enough to go to Vegas and get free drinks. But anyways, everyone's always like, oh my god, the drinks are free, ladies. Like, I want to go and play at the casinos. And it's like, no, it's because you're going to lose. You're just paying for the drinks by playing the games. No one understands this. Well, I mean, if you're having a good time, ask yourself, was it worth 50 cents? And if the answer is yes, then go right ahead. If you're showing up there because you're like, I need to, like, pay off my mortgage, it's not a good idea. like, yes, it's a game. That's the whole point. And it's actually created so that you're not going to actually lose a lot, hopefully. I mean, that's the average. Some people lose more, some people win more. But on average, everyone loses. On average. But there still will be winners, and there still will be people who lose way more. So this is actually, the drinks, yeah, they also do that because the drinks make you want to play more, yes. But, like, this is the whole idea, like, shit, I was gonna say something about this, about this probability distribution. Yeah, it was something about the fact that they just choose the numbers to make it so that it's negative. Oh, shit, I remember. Okay. So, most slot machines now, like, they aren't actual mechanical devices. What are they? Yeah, there's like a little computer in here. Okay, now this is the crazy thing. These are like LED screens or LCD screens. And has anyone ever like taken a video of a screen on your phone? What do you notice? Like when you're looking, here's your phone. Yes, exactly. Those are called scan lines. So this is like the little thing, you see these little lines that keep moving. Okay, and then actually that has to do with like how the screen updates at a particular rate. It's called something called the refresh rate. So anyways, a bunch of Russian like mobsters or like mafia guys or something, they like hired some computer scientists, and what they did is they ripped apart the little computers inside of the slot machines, and they like looked at the code, and they found out that there were some issues with how the code worked. So what happens is like the computer needs to decide when people are going to win. And what happens is the computer basically says like, well, because like, does it make sense in Vegas? They want people to keep on seeing other people win constantly. So the computers are designed to have a payout every so often, right? Because they don't want people to get like demoralized. Does that sort of make sense? So, yeah, right, exactly. So because they want people to not just like give up and leave. So anyways, so what happens is they notice that something would happen on the screen right before it was about to pay out. So does it make sense? There'd be like this little glitch or something. And now it happened too fast for like the eye to see it. So they wrote a program so that they would walk around with the cell phones and they would have the camera look at the slot machine, and then they would just sit there and wait. And then all of a sudden, like the camera, like the program, it would run, and then it would say like on the screen, like alert, like this slot machine is about to pay out, like we saw the glitch. And then the people, so what the Russian mob would do is they would like send people to Vegas with like $500, and then they would win like 20 grand because they would just sit with this little program because they knew exactly what the machines looked like. And like they wrote this program so that they would just like sit there and wait, and then the thing would say like, oh my god, it's gonna pay out soon, like you should start playing that one. And so they actually caught them because they noticed that there were like a bunch of people like going from like this little city in Russia to on flights to Vegas. And they noticed that a bunch of them kept on going back the other way at the winnings. And they were like, why the fuck are all these people going to this little town in Russia? And they're like always winning. And then like basically they figured out that that's what happened. And then they like destroyed all those machines. Because they were able to figure out when they were winning. It's pretty cool. So anyways, you can use like statistics and like computer science to do this sort of stuff. It's like the only way. It's the way you can stick it to the man. Cause mm-hmm. 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 Right. Yeah. Yes, exactly. They're rigged in different ways, and if you're really careful about it, you can like figure out like when it's rigged to pay out or not pay out. And like these people made a shitload of money because they were able to figure out like, oh, it only pays out when this little glitch comes on the screen right here. And so they just wrote a computer program that like the cell phone just looks for the glitch on the screen, and then like it would flash lights like, you know, this one, play it. And they made a bunch of money. Yeah. It's like sort of nuts though, because it takes like a lot of work obviously to figure this stuff out, but like this is how our world works. So understanding this is is like important to understand like how the world works. Okay, so this should remind you. Let's write this down. The expected value of a probability distribution should remind you of the mean of a numerical variable. In fact, they're the same thing. So just like how we talked about like the center of a distribution is like the most commonly occurring value, or it's what we think of as the average value, the expected value of a probability distribution is the same thing. Like in this example, the typical payout is a loss of 50 cents. Right? Remember we got the expected value is negative 0.5. So a typical, this is the typical payout. In other words, you can expect to lose money, not make money when you play this slot machine. Does that mean that not everyone does that mean that everyone's a loser? No. So does this mean everyone is a loser? No. What it means is that if like enough people play, typically they will be losers. And in fact, typically, how much money will they lose? 50 cents. To be honest, I think like all of capitalism is rigged in this similar way. The whole system is like sort of like I think designed so that like typically everyone ends up in debt or something like that. Which is why like, you know, that sentiment at the beginning about canceling our debts, not sure if it's going to happen. I mean, I think the whole thing is designed to work like that. I hope people figure out how to force them to do that, but you know, fingers crossed. Well, yeah, but like what I'm trying to say here is that it's designed to be this way, right? And if you start believing that, then it's sort of like I'm like, I think this is what they intended to happen. Makes me wonder if they're actually going to pass this student loan reform. I mean, we'll have our answer pretty soon. If they don't do it in the next couple of years, then we know that they designed the system to be like this and everyone's cool with it. Or at least the people in charge are cool with it. Well, everyone who matters, quote unquote. Everyone who, let me put my other hand up, matters is cool with it. So we'll see, you know, us at the bottom of the food chain, we'll see if there's any changes. Again, fingers crossed. We'll see. But the plantation has been running for a couple hundred years in America now, so I'm not holding out too much hope. So anyways, on to a less depressing topic. You're like, wait a second, it's all statistics. Yes. So anyways, like I worked on a PhD in math, and like I ended up teaching myself about like machine learning and statistics and all that sort of stuff on the side, and it's pretty intense when you realize like how much the world is based on these concepts and people don't even realize it. Like has anyone ever heard? Everyone knows what hedge funds are, right? What are hedge funds? Yeah. Okay, so hedge funds aren't necessarily huge, but yeah, they usually are. So what they do is they buy stocks. But here's the problem. Let's say you buy a stock at $5 and then it goes down. What happened there? Like if you buy a stock when it's $5 and the next day it's now worth $4, what has now happened to you? Yeah, you lost $1. So you lost $1. Okay, what hedge funds do is they hedge against this. If they're worried that the $5 stock they bought might go down $1, they buy something called an option. And an option is basically like insurance against a price drop or the price going up. So let's say insurance against a price drop. So what you do is it's basically a bet. So when you buy a stock for $5 and you're worried that it might go down to $4, you buy an option. And the option is a bet. You're like, okay, so this is what the option is. You're like, so what you do is, so an option is, let's put option equals, a bet that the price will go down. So if you bet that the price goes down and it goes down, do you win or do you lose the bet? You win. So what you do is you pay. So you pay like 25 cents. You buy an option. You're saying like, hey, I'm going to pay 25 cents. And if the price goes down $1, I will win $1. But what happens if the price stays the same? You lose your 25 cents, right? So if the stock goes down, it loses the $1. Because of your option, you win $1. Did you actually lose anything? No, that's what hedging is. That's what hedge funds do. This is called hedging. So hedging is when if you buy a stock, you also buy the hedge that goes with it. The hedge that goes with it is a bet against the stock, but it's a small enough bet and it only pays out if the bad thing happens to cancel out your loss from the original stock. Okay, so like everyone who's all about like buying like GameStop and that sort of shit, if you aren't hedging, you're just gambling. So what you can actually do is you can make a sequence of stock purchases so that no matter what, you will still win. Okay, that's what hedge funds do. You can actually do this in Vegas. It's pretty fun. I'm going to tell you about this. I mean, it has to do with statistics, so you might as well like learn about it. Okay, does everyone know what March Madness is? Okay, tell me, what is March Madness? Yeah, so college basketball, right? Okay, so let's say you have Team A versus Team B, and you have Team C versus Team D. Okay, let's say that you place a $5 bet that Team A wins. Okay, what happens if they lose? And you lose your $5, right? Okay, cool. Okay, so what you can do is that you can hedge against this by doing something called a parlay. And a parlay is multiple bets. So what you do is, does everyone know what a bookie is? Yeah, the bookies are the people who take the bets. So you call it, there's a word for it. Sports. Shit, what's it called? It's not the sports bet. Okay, let me look it up. I can't remember. Sports book? Yeah, sports book. So the sports book is where you go in Vegas to make these bets. It's actually pretty cool. So you go there and it's basically just gambling on the freaking March Madness. So let's say you go and you place a $5 bet that Team A wins. If Team A loses, you're out of your $5. So what you can do is make another bet wrapped in with another bet. So what you'll do is you'll make a $5 bet that Team C wins. And in that, you'll make a parlay in which you'll say, but I only win if Team A loses. Okay, so if you look at your first bet, you only win if Team A wins. And you lose if Team A loses. So if you lose this bet, do you see how that now opens up this bet to win? And then you also need that to happen. So this is like you're betting both that Team A wins and Team A loses. And you can actually calculate it just right so that no matter what, you still make money. It's pretty fun, actually. You can use statistics to do this. There's actually a bunch of people now who are like, because like online sports betting is like becoming illegal, they're like basically setting up systems so that you can like bet on the brackets and like you're almost assured to win. But anyways, it's pretty cool. I highly recommend if you're into betting and gambling and stuff, that you research how to do this. I go with some friends to Vegas every year, and basically they show up with money, and basically if enough people play, like someone's gonna win, and it like funds the whole thing. It's pretty fun. So yeah, this is like another reason to play, to learn how to do this. It also basically works the same as the stock market. It's basically like the strategy that the hedge funds have. Right? This is the idea of hedging. That, well, what happens if I lose my original bet? I would like a bet saying that I'll lose so that no matter what, I'll win something and recover my losses. So anyways. I want to end early today on this like happy note about the fact that you can use statistics to like make money in Vegas. How does that sound? Just gonna end a little early. Okay, so please sign in that you were here. I'm gonna click the stop record.